Welcome to solverfy.
In the following problem, we have an electron in a one-dimensional infinite potential well. We need to find out for what higher quantum number n plus 1 and a lower quantum number n is the energy difference between n plus 1 and n equal to delta times the energy difference between 4 and 3. Now there's a small correction in the problem. This is actually supposed to be 3 times E43. So let me make it more clear. The problem says that we have to find higher quantum number and lower quantum number such that the difference is delta 43, but that is not true. It is supposed to be 3 times of delta 43. Otherwise, you will not get any reasonable answer. So let's try to first evaluate this part. We know that the En plus 1 minus En can be written in terms of the E1, which is energy of the ground state, and then n plus 1 whole square minus n square. And this then evaluates to 2n plus 1. So what is delta E43 in this case? So we can work around the same thing, and you will notice that that is equal to 4 square, which is 16, and then 3 square is 9, and that is equal to 7 E1. So we need to find this is equal to 3 times of this. So E1 into 2n plus 1 is equal to 3 times of this, which is 21 E1, and this implies 2n plus 1 is equal to 21, which is true only when n is equal to 10. This is the only option. So we get that the higher quantum number n plus 1 is supposed to be 11, and the lower quantum number n is supposed to be 10. Now we move to the other part. In the next part, we need to show that there cannot exist any quantum number such that the energy difference between E n plus 1 comma n is equal to 2 times of delta E43. So if we write down the same equation, we get 2n plus 1 E1 is now equal to, because this is 7, so we get 14 E1, and that gives us 2n plus 1 is equal to 14, or n is equal to 13 over 2. Now as you notice, 13 over 2 is not an integer, so there does not exist any n which satisfies this relation, any integer n, because n is supposed to be in integer values. So that is why we do not have any quantum number which satisfies this relation.